What's up, Korea? Excited to be here. As she mentioned, I'm Nick White. I'm the COO of Celestia Labs. And today I want to talk about modular blockchains, which you may have heard of, but specifically I want to talk about the moment in time that we're in, which we're calling the Modular Expansion, and also the bigger picture path to 1 million rollups, which I think is the end game for modular blockchains. So first, I want to cover some context. So I want to go over what modular blockchains are and so the problems that they solve. So everything starts in 2008 when Satoshi Nakamoto published the Bitcoin white paper. And what was so groundbreaking about Bitcoin was that it was the first time that you could have a system that could have rules without rulers. And when you compare this to legacy systems of cooperation, if you wanted to have rules, you needed a powerful entity or a set of individuals who were the rulers that would enforce those rules on everyone else. And in blockchain-based cooperation, you're able to eliminate that power hierarchy and just have the participants in the system enforce the rules themselves. And so this is really powerful, and I think the core innovation of what blockchains enable. And the way that this works is that the participants of a blockchain run nodes of the network. And what a node is basically a computer program that knows what the rules of the chain are and is constantly checking the chain and verifying it to ensure that those rules are being followed. And if they're not being followed, then the node will basically reject those blocks from taking place and being finalized. And this is great, except that it has a really hard constraint in that it's not a very scalable system. So any monolithic blockchain, you have to download every single transaction and verify every single transaction one by one. And this just doesn't scale because as the number of transactions increases, the amount of data you have to download and transactions to verify increases in kind. And eventually users and the participants are no longer able to verify the chain, and you lose that core value proposition of decentralization. And so what this means is that monolithic blockchains have a fixed block size, and as there's more and more demand to use a network, the fees increase and make the network yet less usable. And so you have this fundamental trade-off basically between increasing the block size but losing decentralization, or keeping the block size small and maintaining decentralization but then having to deal with high fees. And this has led to forks in Bitcoin like the Bitcoin Cash fork and many other sort of similar things in other ecosystems. Then the second major, I would say, advancement in blockchain architectures happened in 2013 when Vitalik published the Ethereum white paper. And the core innovation of Ethereum was that if Bitcoin was a calculator with very specific limited set of rules that it implemented, Ethereum was this flexible sort of universal blockchain that anyone could implement their own rules on top of as smart contracts. So it really opened up a whole new realm of new applications that you could build on blockchains. But there was one constraint, which is that the Ethereum computer came preloaded with a certain operating system, if you will, or virtual machine, the Ethereum virtual machine. And this essentially limits the kinds of applications that developers can build on top of Ethereum. Similar to if you had someone gave you a computer, but it came with Windows installed on it, you wouldn't be able to run Mac or Linux applications on top of that computer. So this is the same kind of idea with a monolithic blockchain like Ethereum. And so fundamentally, you're kind of still constrained on this, on a monolithic blockchain like Ethereum. And this leads us to the third sort of evolution in blockchain architectures, which is the introduction of modular blockchains by Mustafa Al-Bassam in 2019 when he published the Lazy Ledger white paper. And basically the core insight that Mustafa had is that you could actually go back to first principles and decompose the core functions of a blockchain into separate layers. And each one of those layers could be optimized for that purpose. And then you could recombine this stack to still build end applications. And when you approach things this way, you solve those two core problems that we were just talking about with monolithic architectures. So first, you solve the problem of scalability. So instead of having to download all the data and verify every single transaction one by one, in a modular chain, you can just download a tiny sample of data and verify a single proof that all these transactions are valid. So what this means is that when the amount of transactions that the network needs to process increases, you're still able to basically verify the chain. So you don't have this problem of needing to limit the block size. So modular blockchains can actually scale the block size with more demand in the network, so long as there are enough nodes, light nodes, verifying the chain. And so modular blockchains circumvent this trade-off of big blocks. You're able to have big blocks and low fees while still maintaining high decentralization. And then the second thing that modular blockchains do that's unique is that they separate out execution from the rest of the stack. And what this means is that you're no longer locked into any specific execution environment. So on a modular blockchain like Celestia, you can run EVM, but you can also run Solana VM or Wasm or Fuel or Cosmos SDK or your own custom execution environment. You're not limited to any given execution model like you are in a monolithic blockchain. So again, rather than being stuck with Windows, for example, you can run Mac or Linux applications. So it kind of ends that trade-off and that limitation of monolithic blockchains. And so if Bitcoin is a calculator and Ethereum is a computer, then you can think of Celestia and modular blockchains as a cloud computer. And in the Web2 cloud stack, you have a data center like AWS, that's the foundation that provides this scalable sort of like raw resource of compute that developers tap into to deploy custom sort of virtual machines to run their applications. And it's the same in the Web3 modular stack, except that instead of a data center, you have a data network like Celestia that provides the raw resource of block space that then blockchain developers tap into to deploy their own custom execution layers, also known as rollups, like virtual blockchains essentially, that are customized for their use case. So anyway, with that all covered, I want to shift gears and talk a little bit more about the path to 1 million rollups, and specifically the moment that we're in, which I refer to as the modular expansion. So you might be wondering to yourself, well, I mean, why 1 million rollups? It sounds like, I don't know, just kind of unrealistic, or just like why is that an important goal to strive for? And that's a very fair question. So let me explain why I think it's important. I think that the blockchain industry today is sort of in a similar state that the early internet was in the 80s or 90s, when there were very few servers or websites, there were very few users and applications. But if you fast forward to the internet today, the internet is huge and has hundreds of millions of websites and applications, and there are numerous, killer applications of the internet that people all over the world use on a daily basis. And I think that the path, the way that the internet was able to evolve to this like end game state is that, first of all, the infrastructure for the internet got much more scalable and flexible. And then second of all, a bunch of innovative application builders leveraged that, like the advancements in infrastructure of the internet to build these killer apps that we all know and love. And I think bringing it back to 1 million rollups, I think that the 1 million rollups is sort of like is analogous to the end game state of the internet, where I think what we need to get there is essentially to build super scalable and flexible infrastructure via the modular stack, and then have a bunch of really innovative application developers leverage the unique capabilities afforded by the modular stack to build and discover these killer use cases that are going to make Web3 like useful and help change the world essentially. So where are we today? Well, the modular stack is still kind of in its infancy and still being built out. But late last year, Celestia launched mainnet, and it became the first modular data availability layer. And this was a similar moment to sort of the advent of like broadband, I think, in the evolution of the internet, in that it opened up a whole new range of capacity, of like bandwidth, essentially, for blockchain-based applications. And it's sort of like the big bang moment for the modular blockchain ecosystem, in that it's sort of like sparking a lot of activity, and is sort of like the first, I would say, big like moment to spark the rest of like the innovation that still needs to come. And after Celestia launched, a bunch of layer 2 protocols have since migrated to use Celestia for DA, and it's kind of demonstrated a lot of the advantages of using this stack. So Manta has, over $1 billion in TVL, has migrated to Celestia. We have Avo and Lyra, which represent collectively over 70% of DeFi options volume on Ethereum. And the L2s that have migrated have seen a cost reduction in their DA fees by a factor of 100x, and they've saved millions in transaction fees, and passed on these savings to their users. And like the transaction fees for Ethereum L2s on Celestia is now on par with those on Solana. So there's been, I would say like a real leap forward in terms of the usability of these systems. But it's not stopping there. And even earlier this morning, it was announced that Celestia is going to be launching Blobstream, which is a data availability bridge onto Base. And what this is going to enable is essentially people to deploy L3s that settle to Base, so that they're no longer constrained by the specific execution model of Base or the sort of execution bottlenecks of the Base L2, and scale that ecosystem dramatically. And so one way to think about what Celestia does is a sort of, it helps with Celestia underneath, you can kind of scale any ecosystem. So whether that ecosystem is Ethereum or Bitcoin, where there's a growing number of L2s that are being developed, Base, or some other ecosystem yet to be integrated. And it's important to note, though, that Celestia is really just one piece of this much bigger modular movement. And the modular stack is really quite wide and diverse, and there's lots of different components that are being built by, I think, over 100 different teams. And it really, like, the modular stack is so ambitious, and the idea of getting to this world of 1 million rollups is so complex and hard that it's going to take a village. It's going to be a collective effort over many years by many, many different people. And so with that in mind, I want to just talk a little bit about the 4 core layers of the modular stack and what the end game for each of them should look like, and where we are today and who's building some of the most promising solutions. So the first layer of the modular stack is data availability. It's really the foundation of the modular stack, in that it provides sort of like the throughput of block space upon which all the L2s and rollups run. And data availability is also important for the security and verifiability of every rollup. So the end game for the DA layer is to have really, really abundant block space, and to make sure that that block space is cheap to verify. And obviously, if we're going to have 1 million rollups, you're going to need like hundreds of megabytes per second, or maybe even gigabytes per second of DA throughput to meet that demand. And where we are today with the data availability layer of the stack is that so far we have Celestia, which is live, and we have recently EIP 4844 launched, and this is a step in the right direction, because it's increased the throughput of the sort of like DA layer as a whole. And fortunately, there's a bunch of new DA layers that are coming online this year. Avail, which is doing great work with data availability sampling and KZG commitments, kind of like following a danksharding like roadmap, EigenDA and Near. But the reality is, even with Celestia and 4844 and all these new DA layers, we're still very, very short in terms of the overall throughput that we're going to need to support 1 million rollups. So there's going to be a lot of innovation at the DA layer to increase that throughput. And furthermore, there's going to be a need to actually roll out light node adoption, because, as I mentioned earlier, you can't have large blocks without enough light nodes to ensure that those blocks are actually decentralized and verifiable. The second layer of the stack above data availability is consensus. And consensus is all about ordering. And the end game for the consensus layer is that we want to have sort of like fast confirmations to provide really good user experience, so that if I'm a user and I'm sending a transaction, I get a confirmation. It feels very like fast and seamless. But also the consensus layer is really important when it comes to censorship resistance and liveness guarantees. So we want to have decentralized sequencing and sort of a decentralized sequencing so that we can be sure that users don't get censored, and that the rollups, even if a certain sequencer goes down, are still remain live. And finally, the consensus layer is where the MEV happens. And so it's really important that the consensus layer has some kind of MEV tooling built in so that it can mitigate the negative externalities of MEV for user experience. And so the current progress of the consensus layer is that the reality is that most rollup sequencing is done by a single centralized sequencer. And even if they have, some of them have inboxes that allow you to fall back to the L1, but the reality is that this is not a really good state of sort of like liveness and censorship resistance. And furthermore, very few sequencers have any kind of like MEV tooling built in. But I mean, the good thing is that a lot of them do have fast confirmations. So the user experience does feel very snappy. But what I'm really excited about is that there's a whole cohort of what's called shared sequencing networks coming online in the next year. Things like Astria, Espresso, NodeKit, and Radius, which are basically building decentralized sequencing as a service so that rollups can easily tap into a decentralized sequencer set. And some of them also have built-in MEV tooling, which will reduce the sort of like negative externalities of MEV via things like encrypted mempools or like building sort of like MEV boost-esque types of techniques. The next layer up is the settlement layer. And you can think of settlement as essentially sort of like the bridging and interoperability layer. So, in a world of a million rollups, there's going to be a need for those rollups to connect with each other, to bridge assets, to compose their functionality. And the end game of what this needs to look like is that we need to have fast and secure bridging between all these different rollups. And from a user experience perspective, they should feel like one unified system to a user. We don't want to have users have to manage wallets across every different chain or compose these complex cross-chain transactions themselves. Hopefully, in the end game, that will all feel like one unified system. And so where are we today in the settlement layer? Well, there's been a lot of progress towards committee-based bridging, with teams like Hyperlane or IBC, Axelar, Connex, to name a few. We have the beginnings of intent-based bridging with protocols like Across. And we also have the beginnings of some chain abstraction. So things like Skip API are making it so that a user can basically interact with multiple chains from one unified sort of interface. And so it abstracts a lot of complexity away from the user. But the reality is that there's still a lot to be desired here. On average, bridges are either slow and or quite insecure because they're committee-based. And so we need to move more towards like proof-based bridging, and I think ultimately ZK proof-based bridging to have fast and secure bridges between all the rollups. And then there's still a lot more to be desired on the UX front. But what's really exciting is teams like Polygon are building, proof aggregation, which promises to basically have is like sort of like the end game of bridging, in that you have this fast, very secure ZK bridging between every rollup in the aggregation layer. And then you have teams like Anoma and Flashbots, which are building intents, which allow users to just express something that they want to have happen on chain. And then the solvers take care of all the complexity of making that happen. So I'm pretty optimistic over the next few years that we'll see big strides. And then last but not least is the execution layer. So execution is where applications live. It's where developers build, and it's what end users interact with. And to have a world of a million rollups, what we need from the execution layer is a lot of diversity of different execution models so that developers basically can experiment and customize things and try new things that haven't been done before. And then also execution needs to be very secure. So we need to have really battle-tested, robust, and performant proof systems in order to make sure that all the execution layers that people are building can be truly secure. So where are we with execution? There's been a lot of investment and development on the execution layer, especially when it comes to EVM-based execution. So thanks to teams like Optimism, Arbitrum, zkSync, Polygon, Scroll, to name a few, there are a bunch of different rollup stacks and frameworks and proof systems for EVM-based execution layers. There's been a little bit of progress towards like alt VMs or like non-EVM execution, like Starkware and Dimension, which is supporting Cosmos SDK. But I would say on the whole, we still are lacking diversity in the execution layer. And we're still in the process of really testing out how safe and robust these proofs are. And some of the ZK proofs are still not that performant. So there's still a lot to be desired there. But I'm excited because there's a whole bunch of teams that are bringing Solana VM rollups, Move VM rollups, Wasm. There's teams like Argus that are building custom execution environments for on-chain gaming. And you have teams like Succinct, which are building just generalized ZK VMs and that are quite performant. And so I'm pretty bullish on the future of execution over the next couple of years too. But I just talked about a bunch of different infrastructure, and I just want to make sure that the point isn't lost that all this infrastructure is in service of application developers. Because if the modular stack, just sits idle and is not actually used and leveraged by application builders, then there's no point to build it in the first place. And so the infrastructure is only one half of the equation, and it's the application builders are the other half. And we can't forget that. And so, but I think it's cool is that we're in this really unique moment in the evolution of sort of blockchain technology, where as the modular stack gets built out and comes online, there's this opportunity for application builders to build whatever. The constraints that were previously sort of placed on them via monolithic architectures of limited block size and sort of constrained execution environments are being broken down. And so this is a really good opportunity for people who are ambitious to test the limits and push the envelope of what's possible and discover new use cases. And with that in mind, we're running one of the first modular hackathon called the Infinite Space Bazaar. It's going to be a 45-day hackathon with over $100,000 in prizes for using and testing out different components of the modular stack. So if you're a builder out there, I encourage you to apply and take part. And then we're also going to be hosting the Modular Summit in Brussels in July after ECC. And I encourage everyone out there who's interested to come and participate. We're going to have people from all across the modular ecosystem converge and talk about the latest developments and research in the modular stack. And hopefully it will encourage more of a conversation between app builders and infrastructure builders. And although we're still very early on in the expansion and development of the modular stack, I'm really confident that if we continue to work together as a broader ecosystem to solve the infrastructure problems, and if application builders out there come and experiment and try new things on the modular stack, that I think we will get to a world of 1 million rollups. We'll reach this end game where the blockchain-based applications are as widely adopted and as impactful on society as the internet itself. And so hopefully you're inspired by this and want to partake in this modular blockchain movement. And I'll be sticking around after if you guys want to talk to me. So with that, you can also hear more of my ramblings about modular blockchains on Twitter. But thank you very much for listening, and hope to talk to you after.